맞춰서 아프지 않은 걸 보여 no 말없이 손을 잡고 조금은 놀라서 쉽지가 않은 걸 You know 눈처럼 파랗던 하늘을 벌써 까맣고 감정은 더 깊어져 I gotta tell you this 우리들만 느껴지는 이상한 느낌
Hi, my name is Hakim Dzulkarnain and my metric number is 192396. For your information, dimensional analysis and modeling is a technique to obtain reliable information of a certain object, and we need to obey three conditions, which is geometry, dynamic, and kinematic. Thank you. Okay, for a better understanding, we will do a question. The question asks us to predict the aerodynamic drag force on the prototype. Based on the question, we have a prototype and a model. The prototype is the bigger one, and the model is the smaller one. So from the question, we extract the information, and we have the velocity of the model, the velocity of the prototype, temperature for the model and prototype, and the force for the model only. And the ratio of prototype to model is 5:1. From the temperature of the model and prototype, we will check the table and find the density of model and prototype. So as the whole study of dimensional analysis is like to ratio a model to prototype, so we equate the equation of drag coefficient of model to drag coefficient of prototype. So the formula is here, Fd over half rho v square over a. So this is drag coefficient of prototype, and this is the drag coefficient of model. So the question asks us to find the drag force on the prototype. So on this equation, we have all the information except for the force on the prototype. Then we will plug in all the information that we have, and we will find the force of the prototype, which is 112 Newton. Thank you. Now we are ready to learn how to generate the non-dimensional parameters. So there are several methods for this purpose that have been developed, but the most popular one is the method of repeating variable popularized by Edgar Buckingham. So there are 6 important steps that we need to know to apply this method of repeating variable. The first step is we list the parameter in the problem and count the total number of n. The second step is list the primary dimension of each of the n parameters. Next, the step 3, set the reduction number reduction j as a primary dimension, and calculate k, the expected number of pies, using the formula of k equals to n minus j. The fourth step is choose j repeating parameters. The fifth step is construct the pies, manipulate as necessary. And last but not least, the final step is write the final functional relationship and check your algebra. So these are the 6 important steps that we need to apply before we do the method of repeating variable. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Kadir Jailani and my matrix number is 191883. Can you imagine how a large car can be tested in a small laboratory? How can a ship, how can an airplane can be tested? So we use the dimensional analysis and modeling. So the function of this is to obtain the reliable information. For a car, we can test the car for a prototype and model. We can calculate the drag force, the velocity, the maximum velocity, and everything reliable information in a small laboratory. So there are a few conditions to conduct this experiment. So the condition is the geometry, the dynamic and kinematic of the prototype and the model must be same. So let's continue for the method of repeating and the Dzulkarnain theorem. The first step is list the parameter in the problem and count their total number of n. The second step is list the primary dimension of each of the n parameter. The third step is set the reduction number as a primary dimension, calculate k as the expected number of pi. The fourth step is choose the j repeating parameter. The fifth step is construct the pi manipulated as necessary, and the last step is write the final functional relation and check your algebra. So let's go for an exercise. To enhance your understanding, we will make one exercise. So this exercise is predict the aerodynamic drag force on the prototype. So the keyword is drag force. So this is the information given, which is the velocity for the both model and prototype, temperature of the both, the ratio of the prototype and the model, and the force for the model, which is 94.3. From the temperature, we can get the density for both model and prototype. So from the drag force, we know that the coefficient for the both model and prototype are same. For CD prototype equal to CD model. So this is the formula. After we plug in the information given in this, the finalized equation, we will get the drag force for the prototype, which is 112 Newton. So that's all from I. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammed Danial Syazani with Muhammed Syamsulbahrin, and my matrix number is 19340. I want to ask you, do you know what is dimensional analysis? Okay, dimensional analysis is a powerful technique to obtain reliable information of an object, such as the velocity of a car, by using a scale model instead of a real prototype. This technique is very useful and beneficial as it is less time consumed and save our money. Now, I want to bring you to one place to do calculation. Before that, I want to make in mind there is three necessary conditions you must follow, which is the prototype and the model must be similar in geometry, kinematic, and also the dynamics. So let's go. Okay, now we already arrived at the place that we are going to solve the question. Okay, the question asks us to find the aerodynamic drag force on the prototype. It seems to be hard to use a prototype, and why not we use a model? Next, from the question, we got the info. Here I stated velocity, the temperature, the density, and also the drag force for the model. M here stands for the model, while P here stands for prototype. Next, we must draw the FBD of the model. As you can see here, there is a drag force here, velocity come here, and we use a model drag balance. Okay. Next, we are going to solve the solution. We know that the model and the prototype are the same but different in the ratio. And we simplify the equation of the drag force, and then we substitute the parameters from the info given here, and we got the final answer is 1.12 Newton. So here are the basic steps on solving the question. Thank you. Now I will explain to you guys about the method of repeating variables and backing home of pi theorem. This method of repeating variable was popularized by Edgar Buckingham. Basically, there is a 6 step on solving the equation by using this method. Okay, the first step is we must list the parameter in the problem and count the total number of n. The second step is we must list the dimension of each of the n parameter. The third step is we must set the reduction number of j, and we can calculate the number of k by using the formula n minus j. The first step, we must choose one repeating variables for the step 4. The fifth step, we must construct the k pies and manipulate it as necessary. And the final step, which is the sixth step, step 6, we must write the final functional relation and check your algebra. Basically, there is a 6 step of solving the equation by using method of repeating variables. I think that's all from me. Thank you.